We are from Group 7 and our topic is 3.2 Kepler's law. Kepler's laws are divided into three: Kepler's first, second and third laws. When you were in Form 3, you knew about Kepler, a German astronomist, mathematician and astrologist who modified the heliocentric model according to Kepler's law. What is Kepler's first law? It means all planets move in elliptical orbits with the Sun at one focus. Law of orbits. The planets in solar system have elliptical shaped orbits. The Sun always stays on the focus of the ellipse. The major axis is longer than the minor axis. Most orbits of the planets in the solar system has major axis and minor axis of almost the same length. As such, the shape of the elliptical orbit of the planets in the solar system is almost round. Planets can be assumed to make circular motion around the Sun. The radius of orbit is the average value of the distance between the planet and the Sun. Kepler's second law is mean a line that connects a planet to the Sun sweeps out equal areas in equal times. Law of areas. If a planet takes the same amount of time to move from A to B and from C to D, the area AFB is the same as the area CFD. Distance AB is longer than distance CD. This means the planet is moving at a higher linear speed from A to B than from C to D. Kepler's third law means the square of the orbital period of any planet is directly proportional to the cube of the radius of its orbit. Law of periods. A planet which orbits with a larger radius has a longer orbital period. As such, planets which are further from the Sun take a longer time to complete one orbit around the Sun. For example, the Earth takes 1 year to make one complete orbit, while Saturn takes 29.5 years. The orbits and orbital periods of planets. You can refer to the picture. Kepler's third law can be formulated using Newton's universal law of gravitation and concept of circular motion. Planets make circular motions around the Sun. The centripetal force is the same as the gravitational force between the Sun and the planet. Assuming that the orbit of the planet around the Sun is circular, we can derive the relationship between the orbital period of the planet and the radius of the orbit as in Kepler's third law. Gravitational force acting on the planet is F equal to gmm over r squared. The gravitational force acts as a centripetal force for the planet to make circular motion around the Sun. Centripetal force is F equal to mv squared over r. Therefore, centripetal force is equal to gravitational force. mv squared over r is also equal to gmm over r squared. And we will get v squared equal to gm over r, and this is our equation 1. Linear speed of planet v equal to distance traveled in one complete orbit over orbital period, and it's also equal to 2 pi r over t, and this will be our equation 2. So we substitute our equation 2 into our equation 1. We just put in our formula, and at the end we will get t squared equal to 4 pi squared over gm r cubed. As gm is constant, the formula will form, and the formula is Kepler's third law. And for the smart info, perimeter of orbit is 2 pi r. When Kepler's third law is applied in the system of planets and the Sun, m is referred to as the mass of the Sun. Kepler's third law also can be applied to the system of satellites and the Earth, with m referring to the mass of the Earth. Kepler's third law, that is the formula. It can be formulated by equating centripetal force F equal to mv squared over r, and also gravitational force F equal to gm m over r squared. And these two force will equal to V equal 2 pi r over t. As such, the relationship between orbital period of planet t and radius of its orbit r is t squared equal to kr cubed, where the constant k equal to 4 pi squared over gm.